We are focusing on end behavior and graphing today. So we're putting everything together. We're going to make generalities about end behavior of polynomial functions. We're going to determine end behavior when we are given the function. And we're going to apply your knowledge of zeros and end behavior to be able to sketch a polynomial of a higher degree. So looking at these four beginning graphs, just describe the end behavior. Your options are up or down. Okay, so how would you describe the two ends on the first graph? Up and up. That's how you would describe that. How about the guy in the middle? Or the next one? Down and up. Down and up. The next one? Down and down. And the last one, up and down. Okay. We can figure this out by looking at a graph. We can also analyze a polynomial function. By analyzing a given polynomial function, we can also, there we go, describe the end behavior of its graph without graphing. So what we just did, the whole up, up, down, down stuff, we're going to be able to do that without actually having a graph. All right. So there's patterns we're going to be looking for. Okay. So my functions, my first function is f of x, right? What is this function? It is x squared. So this is still referring to our opening graphs. This is the parabola right there. Okay. What is the value of a? What number is in front of x squared? Just a 1. Is that a positive or is it a negative? It's a positive number. Okay. The value of n. N is my, look right here. It's ax to the power of n. So what's n? N is 2, which is an even number. This was the number 1. This was the number 2. And what did the end behavior end up being? Up, up. All right, G. What was the function given for G? X to the power of 3. That was this one. All right, is my value out front positive or negative? It is positive. My exponent is odd, and it ended up being down and then up. What was H? Negative x squared. Looked like this guy. Is that a positive or negative? Negative this time. Excuse me. Was my n an even or odd? It was even. And what did my n's do? They went down and down. And our last one, m, was a negative x cubed. It looked like this. Positive or negative? Negative. Even or odd exponent? Odd. In behaviors, we're up and then down. Okay. These are all the different scenarios that you're going to get. So looking at these, what do you notice about odd degree functions? Okay, so odd degree. So we're looking here and we're looking here. Whoop. What'd you say? One down and one up. So my ends are opposite. Yeah? So ends go opposite directions. So odd opposite, O-O. Oh, look at that. What do you notice about the even functions? They're going the same direction. They're either both up or both down, right? So ends go the same direction. Come on, pen. There we go. Okay, there we go. Okay, so we notice that's what even and odd exponents are going to decide if my ends go opposite or same direction, right? Yes? The other thing you pointed out to us was the whole positive versus negative thing, okay? So down here, let's focus more on the positive, negative stuff. If A is positive and N is even, what happened to both sides? So positive and even, both of my sides went up. Y went up to positive for both of them. Y went positive. This is the right side. This is the left side. There you go. I don't like that. Can we switch those? I want this to be negative. That makes sense to go left, right, doesn't it? Left, right. That's how you read the graph. Let's switch them. Let's do negative and then positive. All right, if A is positive and my N was odd, what happened on the left side? It went down and then it went up, right? So Y was going negative on the left and then Y was going positive on the right. So we're switching the words up, down to infinity for up and negative infinity for down. A is negative, N is, A is negative, N is even. Both sides go where? They both went down. A is negative, N is odd. It went up first and then down. All right, so do we see a pattern about the whole positive, negative thing by any chance? What do you see? What do you think? The top two are positive, right? Look at the ends. Do you see anything else where they're both positive? Positive, 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 right? There you go, the right side. Here, we have negative and negative. Look at this. Negative, negative. So whether it's positive or negative tells you how the graph is going to end on the right-hand side. Okay? And then if you know if it's odd or even, you know if it's going to begin the same way or the opposite way. All right? Now let's do it with just given a function. We have negative 3x cubed plus 2x minus x to the power of 4. Okay? Is there something you noticed about it right away? It is not in standard form. Good. How should it be written? It should be negative x, yep, minus, yep, plus 2x. Good. All we care about is the leading term, the first piece. That's going to give me all the information that I need to know about how my ends are behaving. Okay, so all we care about here is the negative x to the power of 4. That's all we care about. Okay. My a value, is it positive or negative? A is negative, and my n, or my exponent, it's a 4, which is an even number, right? So what do we know about my ends? They are both going down. So this is a down, down. So my y's are going to negative infinity on both sides. Okay, time to level up. A little bit, but you can do it. My next one is negative 2x to the 5th times f of x. So I want you to take the function we just had and multiply it by negative 2x to the 5th. Told you, this stuff never goes away, does it? It is always there. 4 minus 3x cubed plus 2x. But don't make things harder than what they are. What's the only piece that we care about? The first one. So you only have to multiply the first one, just the one time. Okay? When you multiply, right here, negative 2 times negative 1 is positive 2. X to the 5th and x to the 4th gives me x to the 9th. I don't care about the rest. All I care about is the first one. So based off of that information, is my a positive or negative number? It is positive. Is my exponent an even or odd number? It's an odd number. So we have positive and we have odd. So what are my ends going to look like? It's going to be down and then up, right? Positive means we know it ends going up. Odd means it started off in the opposite. Okay. Your exponent, by the way, even tells you how many turns there are. This is like a little bonus information. Like this guy is going to have 8 turns in between those ends. Number 1 is going to have 3 turns. X to the power of 4, it's going to have 3 turns. So your turns is always 1 less than your exponent. Think about an x squared. Isn't an x squared just 1u? That's 1 turn. So you can always go back to that and build off of it. All right, number 3. Negative 3x squared plus x minus 3x minus 2x cubed. Can't make any judgment, right? Not yet. We got to do some simplifying. So this is negative 3x squared. This is plus x, but this is now negative 3x and positive 2x cubed. How come? Why did their signs change? Yeah, we had to just shoot the negative. Is it written in standard form? Nope. What should come first? 2x cubed. Then negative 3x squared. And then what is that? Negative 2x. So what piece of this do we care about? We only care about the first piece. Is A going to be, is it A positive or negative? It is positive. Is my exponent odd or even? Odd. So what is this one going to look like? Down and then up. Bonus question, how many turns is it going to have? Good. So down and then up with 1, 2 turns somewhere in the middle. Makes sense, right? If it was 3 turns, I wouldn't be ending up where I'm supposed to end up. All right, number 4 wants me to take 3x cubed times the f of x right before it. Do I have to do all of that? No, I really just have to do 3x cubed times what? 2x cubed. I only care about this piece, right? I don't have to do the whole thing. 3 times 2 is 6, x to the power of. Up here, how do we get 9 up here? Okay, so what's it going to be? Oh, I thought it was a 2. I'm sorry. I thought I saw the 3, the 2. You right. 3 plus 3 is 6. Is this a positive or negative term? Is my exponent an even or odd number? I was trying to make it odd. It is even. So what does that mean about my ends? Up and up. So they go up and up. Bonus question, how many turns in between them? 5. Watch. 1, 2, 3, 4, 5. Boop. All right, let's see if you and your partner can do some matching. Okay, so you have 3 functions. See if you can match it with their end behaviors. Which ones, where x goes positive, the y's also go positive. As x goes positive, y's go negative. And the other way, as x goes negative, y's are positive. As x goes negative, y's are negative. They're all going to have 2 answers, by the way. They're all going to have 2 answers. So I want both ends to each function. Does that make sense? Remember, this is left side. This is right side. Okay, so work on that. Let's do the first one together. Which one of these is technically my leading term? Yeah, the highest exponent, right? So this is a negative, right, term, but I have an odd exponent. So it's going to be up and then down, right? So which one of these shows up for the left-hand side? Come on, kids, as my y's go up. So that shows me up. This guy goes up and then down. On the right side, which one shows me down? A and B are both the right side. Look at the end. Which one shows me down? Infinity or negative infinity? Negative infinity. So this goes C and then B. That's what we're doing. This shows up on the left. And this shows me down on the right. So up and then down. All right. Now you do the rest. All right. Check your answers with mine. X to the power of 6 is a positive term with an even exponent, so both ends are going up. The next one, our highest exponent is the 10, so my term is negative x to the power of 10. That's a negative term with an even exponent, so both ends go down. I think odd, opposite both have O's, but the word even has 2 E's. Like it's the same. I don't know. That's kind of how if that helps you, that's what I use in my brain. Our last one has x to the power of 3. That's a positive term with an odd exponent. So it's going to finish on the positive side, but start on the negative side. So we're going to go down and then up, D and then A. Questions before we start actually graphing? It's all coming together now. Yes. The instructions A, B, C, and D, so you have been labeled as like right and left. Yes. How can you tell that? Okay, I can tell because as x goes negative, This is showing the left side. When my x's are negative numbers on the grid, that's the left side of the grid.
Okay.
Yeah. And then the other ones, when my x's are positive, that's showing the right side, where my x's are positive numbers. Yep. That's how you determine left versus right. Good question. Oh. Okay, here we go. We are now going to sketch. So when we're going to sketch a polynomial, all right, we are going to find the zeros and their multiplicities. That was yesterday. Multiplicities. And we do that by factoring. Excuse me. So that was our synthetic division and factoring stuff that we did yesterday. After that, we are going to determine the end behavior of the function. Then we can plot the zeros and use the end behavior to sketch the graph. So I'm going to know where it crosses. I'm going to know where it ends up so that I can draw my curves. Okay. We might not know how high or low the turns go, and that's okay. That's why it's called a sketch and not an exact graph. Okay. Let's do A. 6x cubed plus 6x squared minus 12x. Going back to yesterday, how can we solve for the zeros first? Factor out 6x, good, from everything. So we are left with x squared, we're left with an x, and we're left with a negative 2. We're going to basic factor the inside. So what multiplies to give you negative 2, but it has to give you a positive 1. Negative 1 and positive 2. So what are my zeros? There should be 3 zeros. We're missing one of them. 0. Good. Remember, it's 6x equals 0, x minus 1 equals 0, and x plus 2 equals 0. So that's how we got x equals 0, 1, and negative 2. So we're going to cross in the origin at positive 1 and at negative 2. To determine our end behavior, we look at my leading coefficient. We can go back to our original. What is our leading coefficient? Six x to the power of 3, right? Leading term. So is that positive or negative? It's positive, and is it odd or even? It's positive and odd, so opposite directions, ending in the positive direction, so it has to start down and then go up. So we're starting from the bottom, right? We have to start down, work our way through, and end up. Questions? No? We could get fancy and find the y-intercept, but we're not. But if you really wanted to have at it, you just make your x's equal 0, right? I guess in this case it is the origin. But all the other graphs, you could find the y-intercept. Do we have to? It depends on what it is. I might be foreshadowing for the next problem. Maybe. Our next one is negative 8, x to the power of 3, minus 125. It is a cube. You got to factor it. What if we took out a negative 1 and made it look like 8x cubed plus 125, like that? What kind of special factoring is this? Sum of cubes. We could use our SOAP. So yeah, cube root of both. What is the cube root of 8? Cube root of x cubed. X cube root of 125. 5. Am I going to do plus or minus in between? Plus. Yep, we're doing the SOAP. Same, opposite, always positive. So now it's going to be a squared, which is 4x squared. Opposite sign. A times b, that gives me 10x. And then square the last one to give me 25. We squared the first. We multiplied them together. We squared the last. Okay, so we have two factors. I got this negative 1 out there. Does that negative 1 give you an x-intercept? No. So do I really care about it? No. So when I solve for x's here, here, 2x plus 5 equals 0. I can subtract 5 and then divide by x. We get negative 5 over 2. So what is that, negative 2.5? About right here. Our other one, how are we going to factor 4x squared minus 10x plus 25? Huh? We can't do basic factoring. Can we do slip and slide? Let's think. If I slip 4 to the end, it's 100. Does anything multiply to give you 100 and add to give you 10? I don't think so. We're going to have to do quadratic formula. Don't hate me. It happens. It's okay. We don't have to do it all the way through. Let me show you. Watch. All right. So we have x equals negative b, so that becomes negative 10, plus or minus the square root of b squared minus 4 times a times c, all over 2a. All right. This becomes 100. What is negative 4 times 4? Negative 16. And then what's negative 16 times 25? I believe it is 400. So negative 400. Uh-oh. What's 100 minus 400? Negative 300. Am I going to have any real roots over there? No, they're going to be imaginary roots. So the only places that this is crossing is at the point negative 2.5. That's the only place it's happening. Okay. Okay. This one, we kind of need another point. We could easily find the y-intercept. If you make your x 0, you just get y equals what? Negative 125. We can plot that. So we do have 2 points on there. We didn't have another x-intercept. This one is pretty easy to get your y-intercept. Okay. Our ends. How should our ends behave? This is my leading term. It's a negative term with an odd degree. So we're going to finish in the negative, but we're going to start in the positive. So we kind of curve like that. Okay. So that one was special. We had some imaginary stuff going on, and that's okay. You've done it before. Here, x to the power of 4 minus 8x squared plus 16. It's another special one. Is x to the power of 4 technically a perfect square? Is 16 a perfect square? So how do we say we could split these up? It's the same thing twice. What was it? X squared what? They're both, this time they're both minus. Same sign, both negative. If the middle piece was gone, that's when you have the conjugates, right? But wait, there's more. What is x squared minus 4? There's another special. Now let's difference the squares. So these both break up to be what? X plus 2, x minus 2, both of them. X plus 2, x minus 2, this one also. X plus 2, x minus 2. Now it's a difference of squares. Woo! Any more factoring? Nope. What are my zeros? We have x equals 2. We have x equals negative 2. Problem, I'm supposed to have 4 answers. There you go. They both have a multiplicity of 2. So what does that look like on your graph? On the multiplicity part. They're going to bounce. They're both going to bounce. Okay. What is our n? Someone said up, up. How do you know? It is positive and even. Good. So we have negative 2. We have positive 2. If you wanted to find your y-intercept, could you do that quite nicely? What is it? Real quick. 16. Yes. Make that easy for you also. If we can cross those out, boom, y equals 16. I cross them out because I make them equal 0. Are we understanding how I'm doing that? Okay. So up and up is what it looks like. So, because if I just went across like this, see what happens? It doesn't match, right? Or if I just went down and went up, I don't hit the y-intercept. See how those are wrong? Okay. We got to bounce through them. So we're bouncing off negative 2, y-intercept, bouncing off positive 2. There we go. So it's a giant W. For winning, we're winning at this math game. Okay. Y equals negative 81x to the 4th plus 16. Lots of fun factoring coming back for you. Yes? Nope. Not this one. Not this one. Can you divide this by negative 1? If I divide by negative 1, it becomes what? 81x to the 4th minus 16? Is that a difference of squares? Yes. There's still a negative 1 here, but it doesn't give me an x-intercept, right? What is the square root of 81? 9. Square root of x to the 4th? X squared. Square root of 16. 4. Same thing again. Same or different signs? Different, yes. Good. Uh-oh. Is 9 a perfect square? Is x squared a perfect square? Is 4 a perfect square? That last piece is another difference of squares. So this first one is still 9x squared plus 4. But the last one becomes 3x plus 2 and 3x minus 2. Look at that. Isn't that nice? So that is factored form. What are your zeros? Where are we going to cross my x-axis? Well, this one I would do negative 4 divided by 9 and then square root. Am I going to square root of negative anything? No. So this x squared, 9x squared plus 4 gives me imaginary roots. That's not going to work. How about my blue ones? This will give me negative 2 over 3. This one gives me positive 2 over 3. That's these guys right here. What's your y-intercept? There you go. Leading coefficient? It's a negative, and it's even. So we're going to go down and down. Cross through. Don't stop. There we go. Like that. This one is a refresher on factoring by grouping. Here you could take a negative x squared out of both to give you x minus 1. Here we can divide a 6 out of both to get x minus 1 again. So your factors are negative x squared plus 6 and x minus 1. There we go. So we know one of my zeros is going to be positive 1, right? Over here, if I subtract the 6, divide by negative 1, and then square root, it's positive and negative square root of 6, which is about positive and negative 2.45. So about right there. What's our y-intercept? Negative 6. Good. Leading coefficient? It is negative x cubed. It is negative and odd. So we know we're going to finish in the negative direction, but my first one is opposite. So we're going to start up. We're going to go down. We're going to cut through our y-intercept, turn again, and go down. Something like that. Good job. Work on the homework. Get your practice in. Tomorrow we'll start reviewing for your test.